Hello all. Let's move into problem number 35 now. So this problem talks about circular primes. So what are circular primes? First, let's think about circular number. Let's say 197. If I rotate all these numbers, for example, if I remove this, take the 7 out and move it in front, it becomes 719. Then it can become 971. So these are the three different numbers we can create from this circular from the number 197, and consequently for this example all of these three numbers are primes, so that's why this is called circular primes. Now the problem says if you try to find out the circular primes below 100, there are 13 such primes, and here are the list. That means we will have to count both of them. For example, 79 and 97, so we count it twice. Okay, so that's how we are calculating the circular primes. So the question is asking how many such circular primes are available below 1 million. Okay. Okay, to solve this problem, first we'll do something. First we'll create a function that gives us whether the number is prime or not. We have already created this function many times. I'll do that again here. Then we'll also have to create a function which takes the number and gives us all the circular numbers from these functions. Okay, so let's jump into coding. So in our coding, I'll just add some space. First, what I'll do is zoom in a little bit. I'll create this function def get circular nums. Then I'll take the number, and the number should give me the all list of circular numbers. So let's say I'll just create a number set. Then I'll create another div as 10. We'll know why we are doing this. I'll explain. Then n is equal to 0. So this is basically, first we'll have to find out how many digits in a number. Let's say I have this, and there will be 4 circular numbers because we'll just rotate the number one by one 4 times. So if the size of this digit is 4, then we'll get 4 numbers. That's why we need to find out what is the size of it. And how can we find out? Let's see how. What we can do is, let's say I'll just create this as a number variable, okay, and I want to figure out the number of it. So I'll just take n is equal to 1. Then what I'll do, I'll just take div is equal to 10, and I'll keep multiplying div by 10 until the number is larger than the original number. So what do you mean by this? If I just create while loop, while number greater than or equal to div, then I'll just do div is equal to div multiplied by 10, and n is equal to, I can do n is equal to n plus 1. And if I just do this, so let's see what is the n now. You see n is 3. 4 digit, n is 3 digits, so I think that 3 should be enough. We know the total number of digits is more than that, so if I just increase this by this, then n becomes 4. Yeah, that's enough for us. Okay, so let me just copy this part of the code. So now what we can do is, okay, now let's see what is the div now. Div is actually 6-digit number. Okay, we wanted div to be 5-digit number, and what we can do, so to get back 5-digit number, we'll just do div is equal to div by 10 again. Okay, and if I just look at div, it's 5-digit number. Okay, I'll make it as an integer division. So copy this part. So we got the div. Now what we want to do is, the original number is also part of one circular number. So I want to append this numset dot add the original number, that is our number. Okay, that's our first number. Then I'll just create another loop, because now I know the size of the digit, so I'll just create another loop. I don't need to keep it in range n. That means if the number of digit is 5, I'll run this loop until the level 4. Then I'll have to find out the first digit. I'll just say, okay, a digit. Okay, the first digit is equal to, let's say, number modular division 10. Why is that? let's say this is our number, right? If this is our number, and if I do modular division number, modular division 10, so I get the first digit as 5. Okay, that's what we are doing here. Okay, and I'll say other digits, or raised other digits. I'll say other digits is equal to, or rather other digits, all other digits. So that will be num integer division 10. If I try this num integer division 10, so that becomes rest of the digits. Okay, that's what we wanted to do. And now what we want to do is, if we can append first digit and multiply it by this, then our job is done. Then we get one more number. So what we can do is, now how we can do is, now we already have something called div. Okay, if you see in this case, let's say this is our example, we have this div, and if we multiply div with our first digit, okay, first digit is basically 5 here. If I multiply this, then we get 500,000, and that will be the first number. And then if we add that, if we sum that with the rest of the numbers, that means like this multiplied by 10, and we got this number, which exactly 5 came in the first position, and then rest of the numbers goes in the other position. So that's what we wanted to do. We want to do here. And how we can do is, so we create our next number. I'm just assigning next number is first digit multiplied by div plus rest digit or other digit. Okay, so if I just do that, and we'll get next number, then I'll just do the number set dot add number, and that should be it. If I just do it, repeat this process for n-1 time, then we should get our answer. Now let's just try to return list. I'll just convert it into list number set. In fact, I could have taken it as a list as well. Okay, let's do this. We don't need this set here. Instead of add, I'll just say append, and I'll just say number list, and number list here, number list. Okay, so let's see, expected indented blocks, line 7. Oh yeah, so we'll have to indent here. Okay, now let's see if this is working. I'll just remove some spaces from this. So let's try get circular number, get circular numbers. I'll just try let's say I'll try 1 2 3 4 5. Okay, let's see what happens. So I get 1 2 3 4 5 5 1 2 3. So I got 1 2 3 4 1 2 3 4 5 numbers. If I give 6, I should get 6 number. Okay, so it looks like this is working. If I just try 4 5 2 4, okay, there is, I think we could end up having some duplicates here. Let's say if I try 4 4 4 4, so I'm getting 4 4 4 4 4 times. We don't need that. So what we can do is we can just convert that into a set, because we need only the distinct numbers. Okay, so like that. And then if I convert this to list, then we should get our answer. Yeah, we just want the distinct number. Okay, so we got the get circular number. Now next one we want to do is we want to create the is prime functions. Okay, because I have already done that many times, so I'll just copy paste the code again here. So this is our is prime functions. Here, as you can see, we are taking the number. If the number is equal to 2, then this 2 is a prime number. I am returning 2. Otherwise, if the number is divisible by 2, other than 2, that is not a prime, because even numbers are not prime. And then for the rest of the numbers, I'll go run a loop from 3 until the square root of the number. Okay, and if any of this number divisible by I, then we return false, otherwise we return true. And if we want to test is prime, 3 is true, let's say 12 is false, 13 is true, etc. Okay, so we got is prime. we get circular numbers. Now we'll have to find out the circular primes until the range of 1 million, below 1 million. Okay, so that means we'll have to check the circular prime number for all the numbers below 1 million, and how many such numbers we'll have to count it. Okay, so because we'll have to search, okay, if we take up to 1 million number and if we rotate them, our rotation will also be within 1 million number. Okay, so therefore what I can do is I'll create a dictionary. Okay, so that we don't have to calculate this is prime again and again. I'll create a prime dictionary like this. Then I'll create a 1 million for I in range 1 to 1 million. Okay, and I'll just do like the prime dictionary dot I is equal to is prime. Okay, is prime of I. Okay, let's run this. Okay, so we got it. I think it take only a couple of seconds to run this. Now we'll have to find out the circular prime. Okay, so I'll create a circular prime list. So once I find any circular prime, I'll just keep appending into it. Okay, and again we'll have to search for 1 million for I in range 2 to 1 million. Okay, so and then we'll have to find out if we get all numbers, all the circular numbers has to be prime. Okay, and how can we figure that out? I'll just create a flag. Prime flag is equal to true. Let's say we'll start with true, and then we'll create a loop for num in get circular numbers, because we'll have to get all the circular numbers for this number which we are looping through I. Then we'll have to check, and all of them has to be prime, then only our condition satisfied. Okay, so that means if one of them is not prime, then we'll change our flag to false. So that's why we'll just say if not prime dictionary, because our prime dictionary contains all the 1 million number. Okay, for num, so we are looping through all the numbers within the circular prime, and if one of them is not prime, I'll change the prime flag as, okay, and at the end of it, if prime flag, then we'll add this circular prime list. Circular prime list dot append is I. Okay, so yeah, that should do our work. Okay, let's try this out. Okay, this also takes 4 seconds for me. And yeah, here is our circular prime list. So we got all our circular prime list. Let's check the length of it. We got 55. So let's see what is the question asking. How many circular primes? Okay, so it's asking for the count. I have blocked out again. So here is our problem, 35. So our answer should be 55. Yeah, our answer is correct. And that's it for the current problem. Coming up next is problem number 36.